All right, let's dive in. Today, we're cracking open what Apple is calling a revolution in desktop computing, the 2026 Mac Mini. We're going to peel back the layers on this so-called magic box and see what really makes it tick. And yeah, Apple is not being subtle about it. Their claim is simple. It's bold. This is the future of desktop computing. That is a massive promise to make for a device this small. So that brings us to the big question, right? The one we're all thinking. How on earth did Apple manage to pack this much monstrous power into a box that's barely bigger than a deck of cards? Well, the first gigantic engineering hurdle they had to get over was the most basic one you can imagine, the problem of physical space. Apple's term for this is a 3D circuit sculpture. Their engineers have packed components in so tightly that the gaps between them are less than 1.5 millimeters. It's less like building a circuit board and more like crafting a tiny, intricate piece of jewelry where even air is a luxury. So, how is that density even possible? Well, the secret sauce here is a material called gallium nitride, or GaN for short. This semiconductor is an absolute game changer. It allows power components to be dramatically smaller, way more efficient, and to run so much cooler than the old silicon we're all used to. And this just shows you the difference perfectly. On the left, you've got the traditional PC power supply. You know the one, that big, heavy brick that gets scorching hot. On the right, the Mac Mini's GaN unit. It's tiny, it's internal, and it wastes almost zero energy as heat. It's a complete reimagining of how to power a computer. But when you cram all that tech together, you create an immediate and very dangerous problem, a massive amount of heat. So let's see how Apple managed to tame that inner inferno. The simple reality is, with this much power in a space that small, heat isn't just a byproduct. It becomes the #1 enemy of performance. I mean, without a truly radical new cooling solution, this machine would literally cook itself to death. And that solution is what Apple's calling the Vortex cooling system. It's a pretty clever 3-step process. First, it pulls cool air in from the bottom of the case. Second, it swirls that air across a new copper graphite composite heatsink, which is way better at conducting heat than just aluminum. And finally, it pushes all the hot air out the back, completely silently. And how well does it work? Get this. Even when you are absolutely hammering the machine with 8K rendering, the surface temperature never goes above 45 degrees Celsius. That is seriously impressive. Okay, so Apple figured out the size issue, and they solved the heat issue. The next piece of this whole puzzle was just pure, unadulterated speed. At the very heart of this machine is the M5 chip, and it's built on TSMC's incredible new 2-nanometer process. This ridiculously advanced manufacturing allows for a 10-core design that's a full 30% more efficient than the chip that came right before it. It's just smaller, faster, and it sips power. And this chart really puts it all into perspective. Just notice the lithography difference, 2 nanometers versus 4. That has a huge impact on power consumption. We're talking just 15 to 20 watts for the M5 versus up to 95 for a competitor. And then just look at the AI power, measured in TOPS. The M5 is delivering double the performance. It's honestly in a completely different league. But the speed isn't just on the inside. The external connection is just as revolutionary. The new Thunderbolt 5 standard offers a mind-bending 120 gigabits per second of bandwidth. Now, what does that actually mean for you? It means you can drive 2 8K displays at the same time without ever seeing a stutter or a single dropped frame. And again, let's just see how it stacks up. You compare it to the standard USB 4 you find on most PCs. Thunderbolt 5 on the Mac Mini just offers way more bandwidth and way better display support. For creative professionals, it completely gets rid of data bottlenecks. But in 2026, raw speed isn't really enough. The final element, the real kicker, is intelligence. So let's talk about the Mac Mini's onboard cybernetic brain. To understand Apple's whole strategy here, you just have to look at the M5 chip itself. A massive 40% of its physical area is dedicated just to the neural engine. That's more space than the CPU and GPU cores get. It shows you that Apple is betting the entire future on artificial intelligence. And that big bet pays off with this absolutely staggering number, 100 TOPS. That's 100 trillion operations per second. It's a number so huge it's actually hard to wrap your head around it. So what does 100 trillion operations per second actually get you? Well, as a source material puts it, it's a pocket-sized AI data center that functions without any reliance on the cloud. This means powerful AI models run locally on your device, instantly, privately, and completely securely.
So, we have a tiny, cool, hyper-fast, and wickedly smart machine. This brings us to the final and, maybe the most important question of all. What is the price of this revolution?
This level of bleeding-edge engineering, well, it's not cheap. The sources call this the innovation tax, which is basically the premium you pay for technology that is years ahead of the curve. And to put that tax into real-world terms, just look at this number. A single silicon wafer, made using this new 2-nanometer process, costs the factory a whopping $30,000 to produce. That cost, well, it inevitably trickles down to the final product.
So, when you put it all together, the 2026 Mac Mini isn't just another update, it's a structural revolution. You're getting workstation-class power and a local AI data center, all inside a chassis you can barely even see on your desk. It really makes you question the need for a big, bulky computer tower anymore.
Which leaves us with one last provocative thought to chew on. With this much power in such a tiny, efficient package, are we actually witnessing the beginning of the end for the bulky desktop PC as we've always known it?